All right, so here are your notes on the biconditional statement. So first of all, we need to talk about what exactly is a biconditional. A biconditional is the joining of the conditional and the converse. All right, so since the biconditional is the joining of the conditional and the converse, and then we know biconditional statements are true when both the conditional and converse are true. So if you can determine that the conditional statement was true and the converse was true, then you can also tell that the biconditional is true. If either parts of those are false, then the biconditional is also false. All right, so the symbols for a biconditional is P with a double-headed arrow, Q. And that's just saying P if and only if Q. And the reason we have the double arrow is because if it's the joining of the conditional statement, which goes in the direction P arrow Q, and then the converse, Q arrow P. So if it's going back and forth, that's why we have the two-headed arrow, saying it can go back and forth between the converse and the conditional. And then that makes up the biconditional. Okay? And so we read this, P if and only if Q. All right, so mathematicians are sometimes kind of lazy, and writing out this if and only if, that's a lot of writing to have to keep doing it multiple times. So we like to shorten it, and then sometimes you might see it look like P if and only if, written just with F with an extra F, Q, okay? So sometimes I will write out if and only if, and then sometimes you'll just see if with an extra F, okay? Either way, they mean the same thing. You have to know what we're talking about. Okay. Now, we're going to go through two examples, and then that'll be the end of the notes. So, example 1. A shape is a triangle if and only if it has 3 sides. So this was the last one on your worksheet we just did. His phone. All right, so in this, you know that this is a biconditional because it has the if and only if written, okay? When we talked about the converse, inverse, contrapositive, and the original conditional statements, it would say if something, then something else, okay? And this one has the if and only if written in the middle. So from here, from the biconditional, I should be able to pull out the conditional statement that says if a shape is a triangle, then it has 3 sides. So I can pull that from here because we talked about a shape is a triangle if and only if it has 3 sides. And this is how we came up with the conditional. So if a shape is a triangle, then it has 3 sides. All right, so now is this conditional a true statement or a false statement? This is a true statement. Every triangle has 3 sides, okay? So now once we pull the conditional out of there, we need to also come up with the converse. So once we have the conditional, remember you just switch it to get the converse. So the converse is if a shape has 3 sides, then it is a triangle. So now is this converse statement, is this true or false? It's true, okay? Because if a shape has 3 sides, then we call it a triangle. So then now if we know that the conditional statement is true and we know the converse is true, what can we say about the biconditional? We can say that it's true. So then we come up with these 3 dots. The biconditional is true. And these 3 dots stand for, anybody know? just means therefore. Okay? So those 3 dots, so mathematicians don't have to write it all out. Those 3 dots mean therefore. So that statement says, therefore, the biconditional is true. We knew that the conditional was true. We knew that the converse was true. So therefore, we can go back and say that the original biconditional is also a true statement. All right, so now we're going to go to example 2. So example 2 says, a person lives in Virginia Beach if and only if they live in Virginia. A person lives in Virginia Beach if and only if they live in Virginia. All right, so then we would need to come up with the conditional and the converse. So the conditional, remember we're going to take it from the first part of this statement. So the conditional would be, if a person lives in Virginia Beach, then they live in Virginia. If a person lives in Virginia Beach, then they live in Virginia. And we have to pull it in the order that it was given in the biconditional. So is the conditional statement true or false? It is true. Okay, so if you live in Virginia Beach, then you have to live in Virginia. All right, so the next part we need to come up with is the converse. So we're going to take the conditional and we're going to flip the hypothesis and conclusion. And we come up with, if a person lives in Virginia, then they live in Virginia Beach. If a person lives in Virginia, then they live in Virginia Beach. All right, so is the converse true or false? False. Give me a counterexample. Charlottesville, Richmond, Chesapeake, Norfolk, Suffolk, all of that. Okay, so if you live in Virginia, doesn't necessarily mean you live in Virginia Beach. All right, so now we know the conditional was true. We know the converse is false. So what can we say about the biconditional? The biconditional is false. So we can say, therefore, the biconditional is false. Remember, in order for it to be true, both the conditional and the converse have to be true. All right, and that's all your notes.